Hello everyone, I welcome all of you once again in the series of speed, time, distance. In this video, we are going to talk about the concept of problem on trains. Okay, so train, that concept we are discussing separately because train is a long object. Okay, if a train crosses one pole, okay, a pole, so in that case a train crosses length of itself. So to understand this concept in detail, let's have discussion on this topic. So whenever you will find in question that they have mentioned length of train or any information related to length of train, in that case the length of train you should consider as part of distance. So let's take some example and see how does it work. Say you talk about a train. Okay, this is the train, let's say, and it crosses a pole. This is a pole, right? Crosses a pole, yeah, moving in this direction. So this is the engine side of the train, okay, and this is the tail of the train, right? So in which case, okay, when will you consider, excuse me for my drawing, okay, so when will you consider that this train crossed the pole? You will definitely say in case when the train is, okay, so I'm making this train here at the parallel side, but you need to assume that it's running on the same track, but the position of train now will be here. Do you agree with me? The position of the train now will be here, right? Moving in this direction, and this is the engine and this is the tail. Okay, so you consider any side of the train, like engine side or the tail side. In both cases you will find, now look at this very carefully, pay attention here, that whether you look at the engine side, so engine was here and now engine is here, or you see from the tail side where the tail is here and now the tail is here. In both cases you will see that to cross a stationary object, a thin object, a pole, the train has to cross the length of itself. The train has to travel length of itself. Are you understanding this? Yeah, let's take only one point. Let's take engine. So engine was here, and then to cross this entire pole, the engine has to be here. That means the tail has to pass that pole, right? So engine has to be here. So what is this length? What is this distance? This distance is nothing but length of train. This distance is nothing but what? Length of train. Do you agree with me? This length is nothing but, the distance is nothing but length of train, right? Okay, so that's why we say in problem on trains, when you see problem on trains and in question when they talk about the length of train, consider length of train as part of distance. So we will solve more questions. I have prepared some questions for you. See, I have prepared some questions for you, and I have also prepared a practice set on problem on train. So we'll practice, we'll understand in detail. But as of now, are you clear with this? The length of train should be part of the distance. Okay, if a train crosses a pole, it actually crosses length of itself. Okay, so this is one situation. Other situation is when you take case of two trains moving or two objects moving, right? Let's say one train and you see a man traveling from the other side on the parallel line, so you have a train on the track, and then parallel to that you have a road, okay, where a man is driving a car and coming from the opposite direction. Okay, so here you have to consider two objects are moving, And when two objects are moving, we are going to apply what? Relative speed. Correct. When two objects are moving, we are going to apply what? Relative speed. Okay. So the formula is same, concept is same. Formula is speed equal to distance upon time. Relative speed concept is same, which we are going to use here. The only thing which will be added more is length of train should be part of distance. Only this much you should keep in mind. Rest everything will fall in place. So let's solve some questions and understand this more. So first condition is a train crosses a stationary object. So here question is, a 180-meter long train passes a stationary observer at the speed of 72 kilometers per hour. How many seconds does it take for the entire train to pass the observer? The entire train to pass the observer. I can take the same diagram. Yeah, the same diagram here. Okay. So do you have to make this diagram in exam? No, you don't have to. Yeah, I'm just drawing this so that I can make you understand that this train is moving in this direction. Let's say here is the observer, here is the observer. Yeah, if the train has to pass, the entire train has to pass the observer. Yeah, that means the train has to pass length of itself, right? So we will say that the distance here will be equal to length of train, okay, which is equal to 180 meters here, right? Now speed is what? Speed is given as 72 kilometer per hour, right? Now distance is in meters and speed is in kilometer per hour. So what do we need to do? We need to multiply by what? We need to multiply by the 72. We need to multiply by 5 by 18. Do you remember that? To convert kilometer per hour into meter per second, we need to multiply by 5 by 18. Yeah, we have seen this, we have learned this in the first class. So I hope you're watching this, yeah, watching the entire series. You're not jumping to the random videos. It will be difficult to understand then. So 1 kilometer per hour equal to 5 by 18 meter per second, that we have discussed in the first lecture of speed time distance. I'm using the same constant here, 5 by 18, to simplify. And if I simplify this here, I will say 18 4s are 72 and 4 5s are 20. So here I got 20 meter per second, right? That's only speed. Okay, so we have converted unit so that unit will be in the same form. Yeah, meter per second and distance is in meter. Perfect. Now what do we need to find out? Question said find the time. How many seconds? So find the time. So to find the time, what will you do? To find the time, what will you do? You will say time equal to what? Remember that circle of distance, speed, time. If you want to find out the time, you will say that is distance upon speed. What is the distance here? Distance is 180 meters. Divide by the speed is 20. So the time taken should be 9 seconds. Okay. Well, I'm sure this formula you will be able to apply. But important thing is, are you able to understand that a 180 meter long train passes a stationary observer, a thin object. In that case, the train has to cross length of itself. The train has to cross length of itself. See, in which case we can will we say that train has passed the observer? When you see this situation, this situation, train is still running in this direction, and this is the engine side, and this is the tail, right? Yeah, do you agree? Yeah, so from this point, engine has to be at this point, and this is nothing but the length of train. Okay, so train has to cover a distance which is equal to length of train. This point should be clear, then you will understand this entire concept of problem on trains. Yeah, I hope that's clear. Very good. Okay. Yeah. Next condition, a train crosses a platform or a bridge. Okay. So a condition where you see a train which is crossing a bridge or maybe a platform. Yeah. Okay. So in which case will we say that this train has completely crossed this bridge or platform? So let's see this example and understand. This says a freight train with a length of 120 meter. So this length of train, the length of train from this point to this point is 120 meters. Travel with 54 kilometers per hour. So speed is equal to 54 kilometers per hour. Okay. And there is a bridge ahead that is 150 meters. So the length of bridge, this length of bridge here is 150 meters. All right. How long does it take for the train to pass the bridge? How long will it take? Now here the length of train. Okay. Confusions. When train is starting the journey, when the train started crossing this bridge, we have to consider the engine part is next to the point from where bridge is starting. Okay, until and unless they have said that okay, there is a distance between the bridge and train of some distance, yeah, of some meters, right? In this question you will not find this. In this question it is very clear that there is a train which is 120 meters, there is a bridge which is 150 meters. A train, how much time will it take for the train to pass this entire bridge? Okay, in that case you have to consider the engine point, the starting point of the train is at the edge of the bridge. Okay, I hope this is clear to you. Yeah, so the engine of the train is at the edge of the bridge. Okay, this is what we need to assume. Why do we have to assume this? Because they have not mentioned that there is a gap between the train and the bridge. They have not mentioned that there is a gap between the train and the bridge, right? In that case we have to assume that this is the situation. Is this diagram clear to you? Train, bridge, start, the train is starting here, and then train is running, and then train takes time to cross this bridge. So we have to consider this engine point here is at the edge of the bridge. Okay, there is no gap between the engine and the bridge. All right. Okay, fine. So now it's all formula. I hope you understand that the length of train is part of the distance. Train has to cover the distance of what? 150 meters, which is the length of bridge, but the total distance has to be covered by the train. In this case the total distance will be equal to length of train plus length of bridge. Okay, in this case it is 120 plus 150, that's equal to 270. Okay, so I hope the diagram is clear. Yeah, so go as per the question said that train and bridge, so only consider train and bridge, that's it. Okay, so this is what happened when the train is trying to pass a bridge, a platform, that means another long object, some distance. Okay, the train is trying to cross some distance, so you consider that distance plus the length of train. In that case, you will find that train will be able to pass this bridge entirely, in which case what will be the position of train once it passes the bridge? It will be this. Yeah, isn't it? Train will be here now. The same train will be here now, moving in this direction. Engine and tail. Do you understand? So train has to cross the length of itself and the length of bridge. Okay, if you keep this basic thing in mind, that in the problem of trains, if the length of train is given, then length of train has to be part of the distance, then everything is smooth. Okay, then everything will be smooth. All right, so this is the length, that's in meters, this is in meters. Yeah, then you need to calculate the time, and the speed of train is given as speed of train is given as 54 kilometer per hour. Okay, so to convert into meter per second, we need to multiply by what? 5, and then later divide by what? 18. So we have to multiply by 5 by 18 to convert into meter per second. So this is 15 meter per second. Okay, so you got the speed, you got the distance. Now to find the time, you simply do what? Distance by speed, isn't it? Distance by speed. So this will be equal to what? This will be equal to 270 by 15, not 54, it will be 15. Why 15? Because we have to convert into meter per second. So this is divided by 15. Yeah, distance by speed, that is equal to time. Yes. Yeah, remember this circle. If you want to find out time, then it is distance by speed. Okay, so when the train crosses a thin object, the train has to cover a distance which is equal to length of the train. When the train is crossing another distance, then you add the length of train as part of distance. Okay, you consider length of train also as part of distance, right? So total distance will be this distance plus length of train. Okay, great, very good. Now another case, a train crosses a moving object. This time there is a moving object. When you have moving object, so train is also moving, another object is also moving. Okay, then we will say it is the condition of relative speed, which says speed of one object with respect to other object, which says if both objects are moving in the same direction, the relative speed is minus. When both objects are moving in the same direction, it will be minus. When the both objects are moving in opposite direction, then relative speed will be plus, right? Okay, so we have discussed this in the third lecture. If you want to go through the relative speed concept, go through the third lecture of speed time distance again. Come back to this. So a train crosses a moving object. A train which is 120 meters long is moving with 54 kilometers per hour. It passes a man walking on platform in the opposite direction. So direction is what? Opposite direction. So when two objects are moving in the opposite direction, what do we do? The relative speed will be plus. Yeah, relative speed will be plus, right? At the speed of 2 meters per second. Okay, so speed of this fellow man who is walking, that is 2 meters per second, and speed of the train is given as 54 kilometer per hour. Okay, we have recently converted 54 kilometers into 54 kilometers per hour into meter per second. How did we do it? Multiplying by the conversion number 5 by 18, that, so you get 5 meters per second. Okay, so I can say the speed of train is 15 meter per second. Okay, what is the length of train? 120 meters plus 120 meters. Okay, now what do we need to understand in this question? What do we need to pay attention here in this question? A 120 meters long train with a speed, so much of speed, it passes a man walking on the platform in the opposite direction at a speed of 2 meters per second. How long it takes for the entire train to pass this man? Now tell me one thing, do you see any additional information which states that there is a distance between the train and the man? Not given, right? So in this case we have to assume that, we have to consider that, not assume, we have to consider that the man is standing here. This man is standing here when, okay, and this is the engine of the train. I hope you are understanding what I am trying to say. Okay, there is no gap between the engine and the man. They are parallel to each other. Yeah, they are parallel to each other. Okay, they are parallel to each other. This is the case we need to consider, right? This is what I was trying to tell you in the previous question also. There is no gap mentioned between the train and the bridge, so we have to consider the train engine is at the edge of the bridge. Okay, here there is no distance mentioned between the train and the man walking from on the platform, so we have to consider that they are parallel. Okay, yeah, engine, the starting point of the train, and the man is standing over there. Perfect. Okay, now if you understand this part, there is a simple formula, time equal to distance upon speed. It's a simple formula. Okay, how much time will it take? So distance what train has to cover is length of itself. Yeah, length of train is part of the distance. So distance what train has to cover is length of itself. Tell me, in which case what will be the position of train when it crosses, entirely crosses this man? It will be something like this, that this fellow will be at the tail now. Yeah, here now, right? Yeah, so this is engine and this is tail, right? Again you can see the train has to cover this much distance, which is nothing but equal to length of train, which is nothing but equal to length of train. You getting it? So apply relative speed and understand that when train is moving is a long object, and in question they have mentioned the length of train, you have to consider that as a part of distance. Okay, so distance here which train has to cross is length of itself divided by speed is relative speed. Okay, here you have 15 meters per second and the speed of the man is 2 meters per second. Okay, so this is 15 plus 2, this will be 15 plus 2, relative speed. Objects are moving in the opposite direction, relative speed, 15 plus 2. So what do you get here? That is 120 by 17. So you get approximately 7 seconds. Okay, so we have combined two concepts. Which are these two concepts we have combined? One is length of train, the problem on train, where we have to consider length of train as part of distance, and relative speed. When two objects are moving in opposite direction, the relative speed will be speed of one object plus the second object, x plus y, right? Okay, so this is the third case. Fourth type of case you can see when there are two trains. That means you got two objects which are moving and both of them are trains. You got two length of trains, right? Okay, so let's look at the example and then understand. Two trains of equal length are running on a parallel line, okay, on parallel lines. In the same direction, both of them are moving in the same direction at the rate of 54 kilometers per hour and 30 kilometers per hour. All right. The faster train passes the slower train in 36 seconds. The length of each train is. So, two trains equal length. Both trains are having same length. The faster train speed is this, slower is this. All right. The faster train passes the slower train in 36 seconds. Find the length of each train. Now, if you look at the diagram, if you want me to show this with the diagram, let's say this is the train moving in this direction, okay, and the other train is parallel to this, and the faster train is faster train starts crossing the slower one, right? So let's say this white one is a slower one. Okay, this is the case. Yeah, now the faster one is running with the speed of 57 kilometers per hour and the slower one is with 30 kilometers per hour. Now what you need to learn here, I have kept the faster train behind. Why is that so? Because question said that faster train passes the slower train. Now that is only possible when initially faster train is behind. Then only faster train will be able to pass the slower one, right? Okay. Another thing is I have kept the trains like engine of the faster train parallel to the tail of the slower train. Why is that so? Because when the faster train will start passing the slower one, we have to consider that the engine is parallel to the tail of the slower train. Okay. Why is that so? Why do we have to consider this? Because question has not mentioned there is any kind of distance between the faster train and the slower train. Question has not mentioned that there is any kind of distance between the faster train and the slower train. Yeah, so we have to consider that they are in this situation. They are in this situation where the engine of the faster train is at the parallel. That's the parallel to the tail of the slower one. This is the condition we have to consider. Okay. What I want you to do is I'll tick mark later. Okay, let me tell you now only. So what I want you to do is I want you to draw these diagrams. Okay, this one, yeah, then this diagram, yeah. Okay, so write this case and draw the diagram. Write this case and draw the diagram. Okay, so when you make that the chart for you, okay, the concept chart for you, make sure that you do it, so it will be easy. What is concept chart? When you're making the handwritten notes, make sure that you are also writing the important points, okay, so that it will be easy for you to do the revision. Good. So let's try to find out the time. Formula of time: distance upon speed. Distance here, length of train is part of the distance. Now, do we know the length of train? No. But do we know that both trains having equal length? Yes, given here in the question. So can I consider? Sorry. With this time we'll do a distance formula because time is given there. So we'll do distance formula here. So I will write distance is equal to speed into time. Yeah. Speed is what? Relative speed of first object, which is 57, minus speed of the second object, when two objects are moving in the same direction, relative speed is x minus y. Yeah. Refer to the third lecture of speed time distance. Moving in the same direction, x minus y. Perfect. Okay. But this speed will be in the unit of kilometers per hour, right? So I need to multiply by 5 by 18 to convert into meter per second. So this much of part is only for the speed. Okay, multiply by time. What is the time given there? It takes 36 seconds. So 36 seconds. Okay, to cover how much of distance? Distance which should be twice 2 into x. What is x here? I am considering the length of each train to be x. The length of each train to be x. Okay, question said both of them are equal length. So x plus x, 2x. How much distance the train has to cover? X plus x. Length of train is part of the distance. If there are two trains, add length of both the trains. Okay. Yeah. Okay. Do you want to know why? Do you want to know why? Okay. No problem. Okay. So when the faster train crosses the slower one, in that situation, the faster one will be here. Faster one will be here, isn't it? Yeah, faster one will be here then. That means the train, okay, engine here, when it passes the slower one, the engine has to be here. That means this is length of the first train and then the length of the second train, right? So distance has to be x plus x. Yeah. Coming back to the same root sentence, length of train as part of distance. Consider length of train as part of distance. There is no other distance mentioned here. It's all about length of train in this particular question. So I will consider x, which is length of the faster train, x, which is length of the slower train. I will add both of them, that this much distance has to be crossed. This much distance has to be traveled. Okay, now let's just simplify. Let us quickly simplify. So what do you have here? Simplify. Difference is 27. 5 by 18. 9 3s are 9 2s are. Multiply by 36. 2 18. Okay. Now if I want to find out the value of x, I have to say x equal to 3 into 5 into 18, again divide by 2. Alright, so 2 9s are. Okay, so what do you have? 5 9s are 45. 45 into 3 will get you 135, right, meters. So this is your answer. I hope you are understanding the problem of trains. Problem on trains. I hope you are understanding that. Length of train is part of the distance. Great. Okay, so this diagram is also important. Yeah, don't make this kind of messy diagram. Yeah, just make a simple one train and the other train, both of them are moving in the same direction. So here, length of the first train and length of the second train. Okay, just make this simple diagram. All right. Okay, let's move to the next question. Now here this says two trains, train A and train B, are traveling on parallel tracks in opposite direction. So I am giving another example of two trains. First example was two trains moving in the same direction. Here two trains are moving in the opposite direction. Okay, so this is your fifth case. Yeah, so two trains are moving in the opposite direction. The first case, train passes one narrow object. Okay, it passes the distance which is length of itself. A train crosses another distance, a train trying to pass another distance. Okay, train is trying to cover another distance, and here you have length of train given. So you consider length of train as part of distance and this distance. So total distance will be this distance plus length of train. Third case where moving object. So one thin object, second another length, third moving object, a moving thin object, yeah, a man walking on the platform parallel to that. So apply relative speed. Fourth, two trains moving in the same direction. Fifth, two trains are moving in the opposite direction. So these 5 different cases, if you understand, it will be easy for me to take you to the next level on problem on trains. Okay. So two trains, train A and train B, are traveling on the parallel track in the opposite direction. Train A is 250 meters long and traveling at 30 kilometers per hour, while train B is 300 meters long, traveling with 15 kilometers per hour. Okay. How long does it take for two trains to completely pass each other? Okay. Again, do you have any information about what is the distance between the trains? What is the distance between the trains? Like this is not the case. Like train 1 is here and train 2 is, let's say, here, and then we say, okay, there is some distance between the train. Okay, this is moving in this direction. That is not the case. That's not the case, right? That's not the case. They have, in question, they have not mentioned any kind of distance between the trains, right? So when you consider that the train is trying to pass another train, in that case, you have to consider that they are in this situation. They are in this position. Okay, they are in this position, right? Since they are moving in the opposite direction, so I have to consider engine here and engine here. Okay, right? Now, do I have to talk about the same thing? Length of train is part of distance? I hope not. By now, I'm sure you are clear with this. You're clear with this. Okay, so we'll only apply the relative speed formula and get it sorted. Do we have same units? Okay, no, that's not the case. Train A is length of train is given in meters, length of train B is given in meters, and speed in both cases in kilometer per hour. So what do we do first? We say, what is the relative speed? What is the relative speed? We say here the relative speed will be sum of both the speeds. Why? Because two objects are moving in the opposite direction. That is 45 kilometers per hour. But we need to convert that into meter per second. So how do we do it? We multiply this 45 by 5 by 18 to convert into meter per second. So this will get you 12.5 meters per second. Okay. This as the relative speed. Both objects are moving in the opposite direction. Okay. Fine. What do we need to find out? We need to find how long. That means we need to find out time. So time equal to distance upon speed. What is the distance they have to cover? They have to cover a distance which is length of first train plus length of second train. Okay. Because they are moving in the opposite direction, we'll apply relative speed, which we have already calculated. That is 12.5 meter per second. Okay. In many books, you will find some formulas for this. Please avoid using the formulas. Please, there is no need. Honestly, there is no need. I told you that reduce your efforts of writing or remembering a lot of formulas. Okay. When it is needed, you should learn that. Okay. In these cases, these 5 cases which I have shown you, just learn about the cases. Okay. Formula is simple. Relative speed and length of train is part of the distance. These two things, simple. Okay, so you will say here this is 250 plus 300, that is 550 divided by 12.5 will get you 44. So answer is 44 seconds. Time will, unit of time here will be in seconds. Why? Because the unit of speed is meter per second. We have taken unit of speed is in meter per second. We have taken the unit of distance is in meters. All right, beautiful, great. Let's look at the next question. Again, two trains 200 meters and traveling with 60 kilometers per hour, another with 150 meters and traveling with 40 kilometers per hour, moving on the parallel track in the same direction, guys, same direction. So the moment you see same direction, you will apply relative speed. Okay, same direction. How long does it take for the faster train to completely overtake the slower one? Do you want me to draw the diagram again? Okay, let me do it for you. Should you draw the diagram in an exam? Not needed. You should be able to imagine the case. The faster one is trying to overtake the slower one, so we have to consider faster one is like this. Okay, engine and tail, and the last coach, yeah, tail here, and the speed is 60 kilometers per hour. Okay, and the slower train is here. Why slower train we are drawing ahead of the faster one? Of course, only in this case faster one will overtake the slower one. Think about it. How will it overtake? If the faster one is already ahead, how will it overtake? There is no need of overtaking, right? So you will be able to overtake only when you are behind. The faster one is behind the slower one. Correct? I mean, that's very obvious, isn't it? I hope you are okay with me. You are agree with me. You are agreeing with me here. Okay, correct. Okay, moving in this direction. All right. So I'll just write the relative speed first of all, because both of them are moving in the same direction. That is 60 plus 40 in kilometers per hour, and because the length of train is in meters, we have to convert the speed also in meter per second. So 100 multiplied by 5 by 18 will get you 27 point blah 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 blah. Okay, that's very complicated decimal, no? So let's keep it like this, but meter per second. Okay, we'll do the calculation later when we apply the formula. Okay, how much time, how long will it take? So we need to find out time. So here again, time will be equal to distance upon speed. Distance, what they have to cover is 200 meters and here 150 meters. So total distance, yeah, distance. So whether it is opposite direction or same direction, keep in mind that the distance will always be added. Distance will never be subtracted. Okay, and then divide by 100 speed 5 by 10. And I leave this calculation up to you. Calculate this and write the answer in comment. What's the answer? Okay. Yeah. So this is it in today's video. My name is Shyam Manawat. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.